Today we got a quiz, and it's all just about mole conversion. So you need a couple things. You need a periodic table in front of you. Periodic table. Calculator. And what we're going to do with that is we are going to, all I'm going to do is give you moles. You're going to give me grams. I'm going to give you grams. You're going to give me moles. It's going to be fantastic. Okay? So what we have is we need to make sure you're rounding 2 significant places after the digit, or after the decimal, and I need a label on your final answer. If you are given grams, your final answer is going to be in moles. If you're given moles, your final answer is going to be in grams. You need to show me enough work. And has everybody written this on their periodic table somewhere as a spot to have it on the back? But if you need it on the front, I want you to have this formula. When you're done, you're going to turn it in the A and B folder. There is a little mole ratio spell work you can kind of take a look at. I wouldn't worry about the top. But you can kind of do the bottom and the back if you want here to kind of jog your memory on what we did yesterday at the end of the day. Then we have a couple notes and some practice because we have a challenge lab coming at you on Thursday. We're looking for, this is the page in your note packet we want to get out. Page in the note packet that we want to get out. Awesome. You still do need a periodic table and you need a calculator. And so now we have a challenge lab on Thursday. And on your challenge lab on Thursday, you're going to have to be able to use this information. On Thursday, I'm going to have you pick a card. Put your phones down. Put your phones down. Okay, so on Thursday, you're going to pick a card. And it's going to have a target mass of something you need to make me. And then that means you're going to have to back calculate and figure out how much stuff you have to measure out to do the reaction to get the perfect amount. Okay, so let's talk about how we're going to do that. So, first rule of stoichiometry, life does not begin until your equation is balanced. Life cannot begin until your equation is balanced. So if you're looking at an equation, it should bother you that it's not, I see 1 aluminum, I see 2 aluminums, that hurts on the inside. And then I see 2 oxygens and 3, so I'm going to focus on that first. I can make 6 oxygens on that side and 2 oxygens on that side, and then my oxygens are even, right? What am I going to do to make my aluminums even? How many aluminums am I ending up with now? 2 times 4, so what do I want to put on the other side? I want to put a 4. Very good. Okay. So, the number one thing, yep. Stoichiometry doesn't begin until the equation is balanced. Now, the big thing that we have to remember when we're doing Stoich, okay, the coefficients, and who can tell me which one is a coefficient? The big red numbers are coefficients. Those big red numbers never affect formula weight. Those big red numbers never affect formula weight. So, what is the formula weight of 1 aluminum? Who has their periodic table? Formula weight of an aluminum? 27. If I have a bowling ball that's 27 pounds, and then I get another bowling ball that's 27 pounds, does that affect the weight of this first bowling ball? No. And I can get another bowling ball and another one. I have 4 bowling balls, 27 pounds apiece. Is that going to change one of them? No. So this big red number never affects the formula weight. What does affect formula weight, though, is the subscript. Okay? That's O2. What's the formula weight of O2? 32. Okay? I don't care how many O2s you have, the formula weight is 32. And then, on the last one, to be a little more challenging, I have Al2O3. So let's grab a calculator, fire it up.
102.
Oh, yeah, all right. So what he did was he did 2 aluminum, so 27 plus 27 plus 3 oxygen, 16, 16, 16. And it doesn't matter. I could have 12 of them. I could have 120 of them. It does not affect the singular formula weight. Okay? All right, so yesterday, the last thing we ended with in your lab is this little idea. What the coefficients do tell you is the coefficients tell you the ratio of moles. Coefficients tell, yeah.
Wait, so if it doesn't affect it, then like you have to balance it.
To satisfy the law of conservation of mass, number one. And then number two, because it tells us this next thing. It tells us the ratio of moles. For every 4 moles of these, I have 3 moles of these and 2 moles of these. Great question. Great question. But the law of conservation of mass will be broken if I had 1 aluminum over here and 2 aluminums over there. So we do it to balance it. Okay, awesome. Now, the coefficients tell you a ratio of moles, but they do not tell you a ratio of grams. So whenever you see grams in stoichiometry, you should be itching to turn it into moles. Okay? Now, if you know moles of one thing inside an equation, if you know moles of one thing, you are just a ratio away from knowing moles of everything. If you know just moles of one thing, you are a ratio away from knowing moles of everything. Awesome. So now we're going to do a practice problem. And in this practice problem, we're also going to write the steps at the same time. Okay? All right, here we go. I would like for us to check, first of all, this practice problem is not balanced. That's a bummer. So it's the same up there. We're going to write a 4, a 3, and a 2 coefficient ratio. So first step, balance this. Second step, and we're going to work on reading the problems here in a second, so I'm going to take that part out real fast. Let's pretend I said, hey guys, I want you to write 30.6 grams. If I want to make 30.6 grams of aluminum oxide, my question is, and then I want you to write a question mark with a G. I want to know how many grams of alumina. How many grams of alumina am I going to measure out? And at the end, I'm left with 30.6 grams. Okay, that's the question. All right, so step 1, balance the reaction. Step 1 in stoichiometry is always balance the reaction. Check. We got it. If you're like, man, all these ratios are 1 to 1 to 1, life is awesome, you were doing something wrong. Now, step 2, you want to convert what you are given from grams to moles. Convert what you are given from grams to moles. So up here, we're going to do this problem together. I want 30.6 grams of aluminum oxide. Okay, so I'm going to take that number, 30.6, and we already figured out the formula weight of aluminum oxide. Which one of those 3 up there is the formula weight for aluminum oxide? Is it the 27, the 32, or the 102? Okay, so you were given grams of aluminum oxide, so I want moles of aluminum oxide. And if I want to solve for this, how do I solve for this? Divide 30.06 by 102. I know you can pop that in your calculator. 30.6 divided by 102, and you're going to get 0.30. I keep the O just because of sig figs. Moles of Al2O3. So that's step 1. Balance it. Take what you're given and convert it into moles. Perfect. Now, step 2. We have to follow the coefficient ratio. Follow the mole ratio from where you are to where you want to go. Follow the mole ratio from where you are to where you want to go. So this is tough because we're going backwards. You don't always read it like a book. Are you ready to watch with me? Where am I starting? I'm starting here. I know amount of aluminum oxide. What's that coefficient here? That's a 2. So I draw a little arrow. Well, let me write this other way first. That's a 2. And where is my question mark leading me? That's a 2 to what ratio? 2 to 4 ratio. I'm starting at the 2. I'm ending at the 4. Remember from yesterday, a 2 to 4 ratio. Am I getting bigger or am I getting smaller? We're getting bigger, okay? I need 4 times every 2 of these. There is an easier way to write this that I think would make more sense. 2 to 4 is also the same as 1 to 2. Does everybody see we just divided it out? So you could write either 2 to 4 or 1 to 2. So for every 1 of these, I need 2 of these. So if I'm getting bigger, do you think I'm going to divide or I'm going to multiply? We're going to. We're getting bigger, so we want to multiply. So I'm going to take my 0.3 moles and I'm going to multiply it. Because for every 2 aluminum oxides, I need 4 aluminums to react. So hopefully you can figure that out, maybe even in your head. You make 0.6 moles of aluminum. And then the last step, I asked how many grams of aluminum I needed. So last step here, convert your to grams using its own formula weight. Convert to grams using its own formula weight. Okay, so let's do that last step together. I have moles of aluminum, but I don't want moles of aluminum. I want to know how many grams. That scale back there can't measure out moles. That scale back there measures out grams. So I'm going to say moles of aluminum equal mass of aluminum over the formula. You got moles of aluminum. You want mass aluminum should be over the formula weight of aluminum, which is what number? No. Aluminum.
The formula weight is 27.
27. Oh, did you give me the final answer?
I gave you.
I thought I was looking for the formula weight. You're right. Okay. So we should. Did you say 16.32? Is that it? Just 2. Sweet. Now, if I take 0.6 times 27, 16.2. Very good. You got it. Okay. So, okay. So that is how we do full-blown stoichiometry. Let's see who can keep up because you're gonna have a challenge lab coming up. So keep that to your side. We're going to do one of these here. No, you can do a couple of these and then you stop. All right. Stay with me. It is the same process over and over again. Let's make it happen. I'm going to do one, then you're going to do one, then I'm going to do one, then you're going to do one. Consider the following balanced chemical equation. Can our life start? Yes. How many moles of H2? So I go up here, I write a question mark above here, and I write, I want moles of H2 would react with 2.4 moles of O2. So I got 2.4 moles. Okay. We're just following a coefficient ratio. What is my coefficient ratio in front of my O2? There's no number, so that is a 1 to 2. Am I getting bigger or smaller? So if it's a 1 to 2 ratio, what am I going to do with that number? If it is 1 to 2.4, I'm going to do what? If it's 1 to 2, I'm going to multiply by 2. We're doubling it. I need twice as much over here. Okay, so it's 4.8 moles of H2. Nice. Because for every one of these, I need 2 of those. Awesome. Okay, let's try the next question. How many moles of O2 would be needed to react with 0.32 moles of H2? Now, we're going the other way. My first coefficient is what? That is a 2 to what ratio? 2 to 1. I need half as much. So what am I going to do to 0.32? I'm going to divide it in half. Okay, so we're just playing with the ratios up there. So if you have a 1 to 2, it's getting bigger. You got to multiply. If it's 2 to 1, you're getting smaller. You need to divide. Okay? All right. Let's do one together, and then I'll see if I can't let you do the next one on your own. Consider the following equation. So here's the last hard part, is being able to read it out loud. Consider the following balanced chemical equation. Life is balanced. We're good. We can move forward. How many grams of NaOH? So take your pen, put a question mark and a G over NaOH. How many grams of NaOH can be made if I react 29.04 grams of AlCl3? If you can figure out how to put them up in there, it will be so much easier. Okay? So, first step, take any grams you have and put it into moles. So I know that I have 29.04 grams. I'm going to put it over a formula weight always. Now the hard part is figuring out what formula weight. I have 29.04 grams of what? AlCl3, correct? So get your calculator. Yeah. Let's do it together. How many chlorines do you see? See 3 of them, right? So I'm going to go 3 times 35, enter, plus, how many aluminums do you see? 1 of them, so plus 27, enter. What do you got? 132. Did you add the 27 to that, maybe? Okay. We're looking at 132. Awesome. So, in your calculator, 29.04 divided by 132, enter. There you got it. Now, wait, that is moles or grams? We just divided grams by, that gives me moles, and this is where it's good practice. That's moles of AlCl3, okay? Take your grams, convert it into moles. Step 1. Step 2, we're going to follow a coefficient ratio. So what I normally do is I write me a little arrow. I think it's easiest, just write a little arrow. All right, what is my coefficient of what I know? If there's no number in here, that coefficient is a 1. And what is the coefficient to where I want to go? I want to know how much NaOH. So that is a 1 to what? That's a 1 to 4 ratio. 1 to 4 ratio. Okay. Am I getting bigger or am I getting smaller? Maddox. I'm getting bigger by how much? By 4. So what am I going to do to this 0.22? I'm going to multiply it by 4. Hopefully 0.22 times 4 in your head is 0.88. Okay, that's how many moles of NaOH we got. Okay, awesome. Now, it didn't ask for how many moles of NaOH. It asked how many grams of NaOH. So now I'm going to do moles equal mass over formula weight, which an Na, an O, and an H, if you add it up, is 40. Who can tell me how I algebraically solve for that? What am I going to do with 0.88 and 40? I'm going to multiply. Thank you. So in my calculator, 0.88 times 40 gets me 35.2 grams. Now, I want you to take where you are with that example, and I want you to try another one on your own. I'm going to bring around an answer key, but listen to the way this works. The way that this question is asked, the next part, how many grams of AlO2, NaAlO2, so I'm just moving to here. How many grams of that can react with my 29.04 grams? So all I'm going to do is you're going to start with the same number of moles, okay? And I just want you to do your coefficient ratio, and then I want you to get me a final number. So with that same starting material, I want to know how many grams of this you can make. Draw an arrow, tell me the coefficient ratio, figure out your formula weight, multiply it. I'm going to come around, see where you are at. I'm bringing around a key, see if you can't do that. You can either divide that. Now, this is a 1-to-1 ratio, so because for every 1 mole of this one, I have a 1-to-1 ratio there. So I also have the same number of moles of that one. 1-to-1 means I multiply it by itself. And then now I want grams of that sodium alum. And so I'm going to say X over the formula weight. Did everybody get Na, 1 Al, and 2 Os? All right. Let's take that same idea. we are going to take the same amount again. Look, 29.04. 29.04 grams of AlCl3 again, but this time I want to know how much salt you will make. So again, I'm starting with 0.22 moles of this. Now, take that, box it up. What's my coefficient ratio from here to here? And then can you hit me with the formula weight? So now I want to know, and you can start with 0.22 moles again. Okay, because I'm starting with the same amount every single time. So if I have 0.22 moles of that, follow my coefficient ratio. I want to know how much salt can be made. I'm coming around to see who can hang on to that one.